In example 1, we're going to state the extrema and intercepts of this function. We could investigate this algebraically, but I think we're going to use a graphing calculator for this. Now I've already went ahead and typed all these examples in here, but I'm highlighting this equation, so this is the actual equation here in the calculator. Make sure that you type that in. You can pause the video if you need to and then move on. We're going to take a look at the graph. We're going to go zoom 6 here. Often it's a great idea to start with zoom 6. Notice how this function is a cubic. So it's going to have at most 2 extrema, and also it's going to have at most 3 intercepts. So we want to make sure that we've got a good viewing window. You'll notice here the most interesting part of this graph is up here and also down here. There's many ways that you can get a better viewing window. I prefer to just zoom out, so you can go hit zoom out and then just hit enter. And this will give us a little better picture as to what's happening with this graph. Now I can see my points here and here. You can actually probably do this one just fine like that, but what I'm going to do is I'm going to try to zoom in, but I'm going to zoom in with a box because I know the area that I want to look at for this. We want to figure out where that minimum, or excuse me, that maximum is up there, and then we also want to figure out where this minimum is. So if you do zoom box, just go to the upper left hand side and then click enter or hit enter, and then go to the bottom right hand side and then hit enter, and this will be our new viewing window for the calculator. So there's the maximum, and we've also got the minimum, and this really shows us exactly where those points are. It's not a good idea to use the trace function for this one. The trace function is not going to be very precise. We can try it. As we hit the trace button, you might go up here and say, oh, it's right there, it's about -3.9. Or is it -4.1? So as we click left and right, there's a little bit of a gap here, and it's a little bit ambiguous as to what that is. We do need to be more precise, and the calculator can help us with that. We're going to go to second trace, which is the calculate menu. We're going to find a maximum, so it's number 4. You can either cursor down to number 4 or just hit number 4 on your keypad. The calculator asks us for the left bound, so we're going to go to the left of that point that we want, hit enter. The calculator asks us for the right bound, so now we're going to go to the right. By the way, only the left and the right cursors work because you're just changing the value of x as you go along this graph. The up and the down do not work. Hit enter. You can see the little arrows pointing towards the area that we want, and you can guess. You don't have to be super precise with the guess. You can just guess anywhere in the middle here and just hit enter. The calculator will actually calculate the maximum for you. Sometimes there's a little bit of an error when the calculator finds it, so yours might be like -4.00001 or -3.99998. But you need to be a better math student and understand that the maximum actually occurs here at -4, and this calculator actually gives us that value. So the maximum for this one, and then we want to list also the y value is 28.6 repeating, or 28 2/3. So we're going to list this as a maximum at -4 and 28 2/3, and you could do 28.6 with a little bar over it, that's fine. We also want to classify what kind of maximum this is. You'll notice that at this y value, it's not the highest y value that the graph goes. Over here, the graph continues further up, and so the y values over here are more than this maximum value. So the maximum value here is relative to this area of the graph, or this local area. So we're going to classify this as a relative maximum. Please do this. Please state whether it's relative or absolute. We want to calculate this minimum right here now, so we're going to go to second calculate. You can just hit number 3 on your keypad, and that will get you right to that calculation function. So we're at the left bound is anywhere to the left. We could actually click right now. It doesn't really matter. The calculator just wants to know where to look. It doesn't know that there's only one minimum here to look at. It needs to know where that is. And so how it does that is it asks for the left bound and the right bound, giving it kind of a section of the graph here to look at. And then it also wants you to guess in case there's a couple minimums in that area. So we'll guess right here. Notice how this minimum occurs at 2.000016 and -7.3 repeating. So it's not really positive 2.00000016. This is an error in the calculator. The minimum actually occurs for this one at an x value of 2. So let's write this one as a minimum. And the minimum is at 2, negative 7 1/3. You could have also listed this as negative 7.3 repeating, or even changed these into an improper fraction, but for now this is fine. We want to classify this. Well, is this the lowest point that the graph ever goes? And we're looking at the y values here. And if we look over here on the left-hand side, this graph will totally continue down here. So there's a bunch of points that have a lower value than this one. And so this one's just going to be a relative minimum. We could use this to find the x-intercepts as well, to calculate the x-intercepts, which is what we're looking for here, which is also called the zeros. You might hear them, well, x-intercepts and zeros are two of the big words that you want to know. And so we're going to calculate a 0 here, and that means the y value is 0. So what we're going to do is we'll do the one on the right-hand side. So it asks for a left bound, hit enter. It asks for a right bound. Again, we're looking for this point where the graph hits the x-axis. And we want to guess, so we'll put our cursor kind of right there. So it's approximately 3.45. We can round to the nearest hundredth maybe. So we'll do our x-intercepts here. And we'll find the first one to be 3.45, 0. The next one, we're going to go to the calculate menu, still go to number 2. This time we need to go to the left of the next one, which is going to be somewhere in here. So you can just go to the left anywhere there. Don't assume that that's 0. Might not be. It might be 0.5 or something like that. We're going to figure it out here pretty quick. It's actually a 0.259, so let's round to 0.26. Always for the x-intercept, the y value is 0. And then we'll do another one. We'll calculate this other one over here. And we'll go to 0. And actually, to do this a little bit quicker, instead of having to cursor, you just type in a value. So like 1, 2, 3, 4, 5, 6, 7 is to the left. So you could do negative 7. Hit enter. You could do 1, 2, 3, 4, 5. So that's negative 5 and hit enter. And the guess might be something like negative 6.5, anywhere in between those other values that we had. So it'll find the 0 here, and the 0 appears to be negative 6.71 rounded to the nearest hundredth, and that would be 0, of course.